In numerical analysis, we get there are so many difference operator like forward difference operator delta, backward difference operator nebula, shift operator E, differential operator D, central difference operator delta, and average operator mu. Okay, and here we define each of the operator one by one and find out the interrelation between them, right? But in successive classes. Here we define only two operator. The first two, this is forward difference operator and this is backward difference operator, and derive the interrelation between them. Okay, and before going to define the definition of operator, we here say that in numerical analysis there are given value of x, that is x0, x1, x2 to xn. Okay, and this all the n plus 1 value here we taken as equispaced or equidistance, because the space difference of each points is h here. That is here x1 this is equal to x0 plus h, x2 this is equal to x1 plus h, and this means x0 plus h, so x0 plus 2h. Okay, and similarly we get all the points x0, x1 to xn, and we write the name of x0, x1, x10. These are said to be nodes or argument. Okay, and here it is also given that the corresponding value of f of x for the given value of x, that is when the x value is x0, then the value of fx this is equal to y0. Okay, and these are said to be entries corresponding to the nodes. Okay, and so these are nodes or arguments and these are entries, and we have to given these nodes and corresponding entries. Now we define the operator delta, that is forward difference operator. And the forward difference operator is defined as delta f of x. This is given by f of x plus h minus f of x. Okay, so if we write here delta y0, then we get this is y1 minus y0. Okay, and similarly if we write delta yi, then this is yi plus 1 minus yi. This is the definition of forward difference operator, and obviously this is first order forward difference operator. Okay, now what is the second order forward difference operator? The second order forward difference operator is given by delta square f of x. This is second order, and the definition of second order is delta of delta f of x, and this is given by delta of this is f of x plus h minus f of x. We write the definition of delta, and delta f of x plus h minus delta f of x. So we get from this relation, we use the definition of delta, we get this is f of x plus 2h minus f of x plus h minus this is given by f of x plus h minus f of x. So we get f of x plus 2h minus 2 into f of x plus h minus this is plus f of x. Okay, and if we use here del square yi, then we get the relation as yi plus 2 minus 2 into yi plus 1 plus this is yi. Okay, and similarly if we define third order forward difference operator, then we get this is delta 3 yi, this is yi plus 3 minus 3yi plus 2 plus 3yi plus 1 minus yi. Okay, by similar manner we write this relation. And similarly if we define nth order forward difference operator, then we write here delta to the power yi, delta to the power n yi, and this is given by, now we first write this and this is yi plus 2 minus this is 2c1, because 2c1 means 2 into yi plus 1 plus this is yi. Okay, and in summation form we write this relation as summation r equal to 0 to 2 minus 1 to the power r into y2 plus I minus r. Okay, if we put here r equal to 0, then we get this is minus 1 to the power r, so this is plus, and this is y2 plus I, and we get the first term. Putting I equal to 1, we get this is yi plus 1 and this is minus. Okay, and this is 2cr also, because the first term is 2c0 and the second term is 2c1 and the third term is also, putting r equal to 2 we get 2c2 and this is minus 1 to the power 2 y2 plus I minus r. Okay, and similarly if we write this result directly by summation form, this is given by summation r equal to 0 to 3 minus 1 to the power r into 3cr into y2 plus I minus r. This is not 2, this is 3 here. Okay, we write this result in summation form. And similarly if we find out the nth difference or nth order difference, or we find here the kth order difference, then we get in summation form, this is summation r equal to 0 to k, okay, minus 1 to the power r into kcr into y k plus I minus r. Okay, we get the definition of kth order forward difference operator. This is given by the formula. Okay, now we define the backward difference operator. What is backward difference operator? Backward difference operator nabla f of x is defined by f of x minus h. Okay, now if we wish to define the second order backward difference operator, then we get nabla square f of x, and this is given by nabla f of x, and this is nabla of f of x minus f of x minus h. So we get nabla of f of x minus nabla of f of x minus h, and we here use again the definition of nabla, and this is f of x minus f of x minus h minus this is f of x minus h plus f of x minus 2h, and we get this is f of x minus 2 into f of x minus h plus f of x minus 2h. So we get the backward difference operator of second order. Okay, and similarly, if we write the third order backward difference operator, this is nabla q y I. We write here yi in place of fx. Then clearly this is given by yi minus 3 into yi minus 1 plus 3 into yi minus 2 minus yi minus 3. And in summation form we write this relation as this is r equal to 0 to 3, this is minus 1 to the power r and 3cr. Okay, because here r equal to 0 to 3, and we write here y I minus this is r, I minus r, because if we put r equal to 0, then we get I minus 0. If we put r equal to 1, then this is minus and this is 3c1 and this is y I minus r, and so on. So by giving the definition of nth order backward difference, we write here delta to the power n, we get k. This is kth order backward difference. Nabla to the power k yi, this is given by summation r equal to 0 to k, and this is minus 1 to the power r, this is k c r, this is y I minus r. Okay, and this is we get the kth order backward difference operator. Okay, this is kth order forward difference operator and this is kth order backward difference operator. Now we try to find interrelation between forward difference operator and backward difference operator. Definition of forward difference and backward difference, it is clear that the forward difference of f of x, this is given by f of x plus h minus f of x. We write here the definition of forward difference, and it is clear that this is the definition of nabla f of x plus h. Okay, this is the definition of backward difference, right? Now if we put f of x, this is equal to y0, then we get delta y0, then we get this is nabla y1, because f of x is y0, so f of x plus h, this is equal to nabla y1, right? Now we get the forward difference operator of second order. So the definition of second order is, we write here directly, this is f of x plus 2h minus 2 into f of x plus h plus f of x. Okay, and we write here f of x plus 2h minus f of x plus h minus this is f of x plus h minus f of x, and we put in the first bracket, this is given by nabla f of x plus 2h, and for the second bracket this is nabla f of x plus h, and clearly this is nabla f of x plus h, x plus 2h minus f of x plus h. So we get this is nabla f of x plus 2h, that is we get this is nabla square f of x plus 2h, right? So we write from this result, we get this is delta square f of x, this is equal to nabla square f of x plus 2h. So we get delta square y0, this is given by nebula square y2. Okay, this is the relation between second order forward difference and second order backward difference. And proceeding in this manner, we easily get the relation between forward difference and backward difference of nth order. We get delta to the power n y0, this is equal to nebula to the power n yn, right? From this relation we get. And if we want to find the relation between delta to the power n yi, then we write nebula to the power n yi plus n. Okay, this is the relation between nth order forward difference and nth order backward difference. And if we want to find the relation of nebula to the power n yi, then we must write in the right side delta to the power n, this is I minus n. Okay, because if we put I plus n, this is equal to I, then we get in the left side I minus n. And these are the relation between nth order forward difference and nth order backward difference. Okay, so this is the first class of the finite difference or difference operator, and we discuss here only two difference operator, that is forward difference operator and backward difference operator, and their definitions and their interrelation, and also for the expression of any order forward difference and any order backward difference. Okay, thank you for watching.